Let's talk about Ohm's law. Ohm's law gives us a relationship between our voltage, our resistance, and current. We spoke about the voltage in our previous tutorial with batteries. So my voltage can be a battery's voltage, which is normally in volts. So for example, we can have 3 volts, and that is my voltage. Then we've got the resistance, which is this little man here trying to keep the current a bit tight there at the moment, and that is in ohms. So 100 ohms, which is normally like R, or a Greek symbol like this. And then current is how fast your electrons move. So when we spoke about introduction in electronics in our first tutorial, we spoke about currents being the electrons. So this little green man can be seen as an electron, and it wants to move through my wire, and it's getting affected by my voltage and ohms. So Ohm's law is actually a formula which is V equals to I times R. So it's my voltage is equal to my current times my resistance. But you can also have it as my current, I, is equal to my voltage divided by my resistance. So this one here we use way more often because most of the time we know what the voltage is of our battery and we know what the resistor value is, and we actually want to work out the current of the circuit, which we'll do soon. So when we look at this formula and we look at this picture, it kind of matches. So if I is our green little man trying to go through the wire, if my voltage is very strong, he can push harder, so my current can go faster. So when my voltage increases, my current will also increase. So when this guy gets very strong, he pushes hard, and this guy will motor through at a big speed. My current, my electrons will go through the wire quickly. So my resistor, this strong man here, if he's strong as well and he makes this pipe very small, my electrons and my current will move slowly through the wire. So that means if my resistance increases, my current decreases. So that is a relation. That's the divide sign. When my resistor gets bigger, I get divided by a bigger number. The same, when this guy becomes weak, my current can go faster. So the resistor decreases, my current increases. So that relationship is known as Ohm's law. And with these formulas, we can do some calculations to work out current, voltage, or resistor. So we only need 2 of these variables, and we can calculate the other one. I'll now show you an example of it. Now that we know that Ohm's law is voltage equals to current times resistance, or current is equal to voltage divided by resistance, we can calculate these values looking at our circuit. So we spoke about resistors and batteries in our previous section, but how do we calculate what current goes through my circuit? So for example, my resistor here is 100 ohms, and I've got a battery a big battery, let's go crazy, of 100 volts. So what is my current flowing through the circuit? So as we spoke about batteries, this is my positive and this is my negative, the long short size. And then my conventional current flows from positive to negative. So it will flow like this back home. So what is this current? So with this formula, we can calculate that I is equal to my volts divided by my resistance. So my voltage is 100 and my resistance is 100 ohms. 100 divided by 100 is 1, and this is 1 amps. So that means the current through the circuit is 1 amps, which is quite a lot. Now let's keep this 100 volts like we did previously, and we increase the resistance. So we make this 200. So what did we say previously? When we increase the resistors, what do we expect? We expect the current to decrease because this little man's getting strong and my current can't go that fast. So let's see if the formula actually matches what we think. So I is equal to my voltage divided by my resistance. My voltage is 100 and my resistance is 200. So 100 divided by 200 is 0.5 or a half. So that means the current flowing through the circuit is 0.5 amps. So when we increase the resistance, my current halved. So we had 100 volts, 100 ohms gave us 1 amp. Now we got 100 volts, 200 ohms, we get half amp. So my resistor doubled, my current went half. So there you can see what we said. When the resistance increases, when my own man gets very strong, my current becomes very slow. So last one, let's say we increase our voltage. We've got 200 volts and we have our resistor of 100 ohms. Again, current from positive to negative, I is flowing through here. We've got I is equal to volts divided by resistance. Now we increase the voltage. So what will happen to our current, we think? Let's see. 200 volts divided by 100 ohms is equal to 2 amps. So we've got 2 amps flowing through the circuit. So we doubled our voltage and our current doubled as well. Look at this picture again. If my voltage man gets very strong, my current will go faster through the hole, electrons will go faster through the wire, and my current will increase. So this is making logical sense when we look at the picture and how it works with our calculations. And that's always nice to see. At the end of this tutorial, you'll see a link where you can click on and go through some questions and where you can calculate some different circuits that I gave you guys. Go through it, let me know what you guys calculate, and message me to see how I can help you. What I want to chat about now is resistors in series. So we spoke about earlier what a resistor is. So a resistor is a component you use in electronics to limit the current of a circuit. So this little man here is a resistor, and we call him Ohm, Mr. Ohm. And he makes it very difficult for current to flow through the wire. So now we want to discuss what happens when I have more than one resistor in a circuit. So here you can see I've got 3 resistors next to each other. When they are connected next to each other like this, we call it in series. So in series just means it's next to each other, connected. So here we've got plus minus again, long side plus, short side minus. So what happens when this happens? Before we get to any equations or anything, let's think about it. So we've discussed earlier about this little man. He's making it very difficult. Now imagine I've got 3 of these men, because that's what's happening. So I've got 1 here, 1 here, 1 here. This poor little amp guy needs to go through strong man or weak man, but he needs to go through someone that's trying to stop him from going there. And he needs to do that 3 times. So do you think it'll be easier for my current to go through or harder? It will be harder. So you will have to go through here. You will go through this resistor, he has to get through this little man, and then he has to go through this resistor, and then meets another man, and this resistor, and he meets another man. So the current keeps slowing down the more it goes through the resistors. So my resistor in series increases. So when I have resistors in series next to each other, my resistance increases. So what that means is, let's say for example, I've got 2 ohms here, I've got 3 ohms here, and I've got 4 ohms here. So these numbers represent the strength of my resistance as we discussed earlier. So what will the total resistance be? Total resistance here will be R total is equal to 2 ohms plus 3 ohms plus 4 ohms, and that is 9 ohms. So when resistors are in series, we add them up because they increase, they become stronger. When we look at this man again, it makes sense. So if we look at this man again, it kind of makes sense, right? Because I've got my current that has to go through 3 obstacles, 3 places where it resists itself. That's where the word resist comes from. It resists the current. So it doesn't want the current to go there quite easy. It will have to work to get through these resistors or these obstacles. So you're probably asking yourself, but JP, why do you want to put 3 there? Why not just put 1 bigger resistor? And that's a good point. So the reason you put 3 next to each other in series is resistors don't come in all the values you have. Like it won't come in 1 ohm and 1.1 ohm, 1.2 ohms. There's only a certain values that resistors have. So you can create series like this to create values that you want for your circuit with Ohm's law that we discussed. Also, sometimes at home, you only have 3 ohm resistors. So you only have 3 ohm resistors. Now I want a 9 ohm resistor, but I don't have it. I don't want to go buy it. So I can use 3 3 ohm resistors in series to make my 9 ohms. So you will use it in different scenarios. So 3 plus 3 plus 3 is 9. So I don't have a single 9 ohm at home, but I've got a whole bunch of 3 ohm resistors, so I can use 3 in series to create the 9 ohms. Now let's look at Ohm's law with resistance in series. So in resistance in series, we discussed that my total resistance is all the resistors added up. So it's not only 3, so if we have 20, we'll go R1 plus R2 plus R3, where this is R1, this is R2, R3, and it can carry on. So you can go R4, R5, R6, and all the way up. So the total resistance is just adding all those resistors. So let's look at calculating the current for resistors in series. So let's assume that we've got a resistor of 2 ohms here, 2 ohms, and 5 ohms. And then we've got a old school 9-volt battery. So what is Ohm's law again? To work out the current, we've got the current is divided by my voltage divided by resistance. These three amigos, these three friends here, all they want to do is just either help or not help the current at all. So we've got our voltage, which is 9 volts. But what about our resistance? What value we're going to put here? It's the total resistance of the circuit. So we've got our total is equal to 2 ohms plus 2 ohms plus 5 ohms. And that is 2 plus 2 is 4 plus 5 is 9 ohms. So my current in this circuit is 9 volts divided by 9 ohms, which equal to 1 amp. So my current flowing through the circuit is 1 amp. So that's it for resistors in series. So you guys saw when we put resistors in series, the resistance increases, which decreases the current because we're adding more men. So we've got 3 of these men trying to make life difficult for my current going through the wire. The volt will keep pushing the same. It's got a strength of 9 volts, but I keep adding defenders. I keep adding people trying to make my current less likely to go through that small hole. So that's another thing, guys. Resistors in series, my resistance increase. At the end of this tutorial, we'll build one on a breadboard and you'll see it in real life.